Today, we're going to do page 151 and 152, which are about graphs. This is kind of fun. So, this page 151 tells us about a pictograph. Now, a pictograph, you probably, how many of you saw these on your iReady? Yeah, okay. A pictograph is a graph that uses pictures or symbols, excuse me, to represent data. This pictograph shows how many books 5 students checked out of the library in 1 year. So when we look at a pictograph, we have to zoom in to figure out what is the important information. So the title of the pictograph is going to tell you what the data is about. So the title of this one says, Books Checked Out of Library. And then we can see that on one side we have student names, and then on the other side we have these little pictures of books. Now at the bottom of your pictograph is the most important piece of information, in my opinion, and it is the little key here that says every picture of a book is actually equal to 5 books. So I see the number one mistake that 4th graders make when they're dealing with a pictograph is they forget to look at the key. Yes, Colin?
We're gonna do multiplication and addition again.
Maybe we'll do a little bit of everything today. So let's look at this. So some questions that you might have about pictographs. Number 1 says, write an addition equation and a subtraction equation that compare the number of books Tarek checked out, we'll call that T, and the number of books Jamarcus checked out, we'll call him J. Okay? So we're comparing the number of books. So if we kind of rewind in our brains, so Ella and Leia, yesterday we practiced making comparison bars and looking for multiplication and addition types of comparisons. So we can see here that it's asking us to compare, right? Compare Tarek and Jamarcus. So let's write some comparison bars. So we'll call Tarek T and Jamarcus J. Who has more books? Okay, so which one? Tarek. So we're going to make his box bigger, and Jamarcus is going to have a smaller box. Can you write up these unit boxes in your book? Yes. Yes. Annie, can you write it? Okay, then we can use the pictograph to find the numbers. All the problems we did yesterday gave us the numbers. So, Matthew, how many books did Tarek check out from the library? You're going to write this in Tarek's box after you draw it. How many books, Matthew, did Tarek check out? 30. Anybody agree with Matthew? Okay, because we're kind of saying 5, 10, 15, 20, 25, 30, right?
Yeah, I counted that.
Okay. And Jamarcus, Jackson, how many books did Jamarcus check out? 15. 5, 10, 15. Okay, so now it's saying write an addition equation and a subtraction equation that compare the number of books. So we know that the difference here is, well, we know the value, right?
15 times 10 is 30.
Oh, you could do a multiplication. Nolan says 15 times 2 equals 30.
Or 30 divided by 2 equals
Or
15.
30 divided by 2. Those would be perfect. So that was kind of what you were asking. Are we going to do multiplication? Okay, except this is asking for an addition or subtraction equation.
15 plus 15 equals 30.
Or you could do that.
And 30 minus 15 equals 15. 30 equals 15. Or 15 equals equals 30 minus 15.
Okay. Oh my gosh, you guys are giving me so many. So, what is the difference? What is the difference, Ryan? Okay, so the difference is 15. Okay. So, let me show you how we're going to compare. We can say Tariq equals, this is different, Jamarcus plus 15. So before we were kind of using the data, using the numbers to solve for the variable, but this is not really asking us to solve for anything. It's just asking us to compare. Got it, Amelia? So can you think of a subtraction problem along these lines where you use T for Tariq and J for Jamarcus and maybe the difference? Aisha?
So it's T minus 15 equals J.
Yes, T minus 15 equals J. Yeah, Ryan? Yeah, yes, good remembering. Yes, Cadence? Will you take one to Jackson too, please? So I use lowercase t and j because that's what they put here. But you could do either way.
You can do J equals 30 minus 15, or J equals T minus 15.
Yep, you could flip this equation around and write it j equals t minus 15. That would also work. Okay, let's look at another one. Okay. Write a multiplication equation and a division equation that compare the number of books Naji checked out, we'll call her N, to the number of books Celine checked out, we'll call her C. Okay, so I'm going to have N and C. Whose box is going to be bigger? Celine. Oh my gosh, look at all the books she checked out.
She did get 40 books.
All right, count them up. How many books does Celine have?
40.
Okay, I agree. I'm hearing 40. And then how many books do you see Naji having checked out? 10. Okay. So now we're thinking multiplication. So now I'm looking at these two numbers, 10 and 40, and I'm trying to figure out how they're related using multiplication. Any ideas? Kate? Brilliant.
Or C divided by 4 equals N.
Yes. Yep. Nolan?
N equals C divided by 4. And
Yes, we can flip this. N equals C divided by 4.
C times 4 equals, oh wait, no. C equals N times 4.
Yes, we could flip this one. C equals N times 4. Okay, all right. We can do some more looking at these numbers. It's kind of like a number puzzle. Celine checked out twice as many books as which student? So I'm looking for Celine. Okay, we already remember Celine has 40. So I'm thinking, you don't have to write this down, but I'm thinking 40 is twice as many as
20.
what? 20. And who has 20 books?
Brooke.
Brooke. 5, 10, 15,
Brooke.
20.
Brooke the book.
Okay. Which student checked out 30 fewer books than Celine? So again, we've got Celine. We love her. She's got all the books. Now I want to know who has, so Annie might write these down, who has 30 less?
Naji.
So how many books am I looking for, Ryan?
10.
10, and now I need to find who has 10 books. It's a guess. It's a name. Naji, that's what I would say. So Naji has 10 books. Okay. Last question on this page says, okay, this one's going to get good. I love these. This one's like when you have to figure it out. The number of books Dawson checked out is not shown. It's a mystery. If Jamarcus checked out 10 more books than Dawson, how many books did Dawson check out? Dawson's not on the list.
You checked out 5 ways.
Ella, tell me you're thinking. Yes?
And Jamarcus has 3 of those letters. That means he has 15 books. But only 2 of those make 10 times. It says that Jamarcus checked out 10 more books.
Brilliant. So Jamarcus checked out 10 more books than Dawson. So I'm thinking Jamarcus equals Dawson plus 10, right? Or if I was thinking in unit boxes, I would think Jamarcus has 15. Dawson has, I don't know how many, but I know the difference is 10. In which case I can subtract, right, to find the solution. 15 take away 10 equals 5. So Dawson has 5 books. Wow, Dawson.
That's a lot of books.
Right? Yes, Matthew, super fast. Okay. Andy, we're going to turn the page so you won't be able to see the last problem. Any questions on those?
No.
That didn't feel too crazy, right? So I want you to recognize how helpful these unit boxes are to help you kind of see the math, right? Okay, now we're going to do a different graph. This one's one we're familiar with. So just kind of think about it, Annie, see if you can remember. A bar graph. This makes me think of iReady. Remember we were making our very own bar graphs. Okay. So the bar graph below, and just like the picture graph, it gives us the same information. We have a title, home runs this year, and we've got kids, but they're down here. Or team members, we don't know if they're kids. We've got Fred, Greta, Kim, Susie, and Devon. These are the team members. And then along the side, we've got the number, and the number of what? These are the number of home runs. Okay. Yes, Miles, what do you see? Uh-oh. Can we finish this page and then go up and get some medicine? Okay. So we're going to use this bar graph to answer these questions. Remember, solve came up yesterday. Cash, solve is the same. When you solve something, solve is the verb. And when we solve something, we find the answer. Answer is the noun. It's what we end up with. Okay. And lucky for us, these are nice and easy to read, counting by 2s. So write an addition equation and a subtraction equation. All right, so we're thinking addition and subtraction that compare the number of home runs Susie hit, we'll call her S, and the number of home runs Kit hit, we'll call her K. Kim. In my brain, I merged Kim and hit. Okay, who hit more home runs? Susie. Okay, I'll give her a bigger box. Okay, how many home runs did Susie hit? So this is where a bar graph can be kind of tricky because we have to go all the way up and then over. Yeah. So I'm going to say Susie has 8. Everyone agree? Okay, Ryan, how many did Kim have?
Kim had 2, and to find out what they had together, you could do S plus K equals 10.
You could do that to find out how many they had together. Yep. What can we do to compare them, however? If we want to do an adding and subtracting, so we need this piece of information here to help us write that equation. Kate?
S minus K equals 4.
What does S minus K equal?
6.
6. So 6 goes in our box here, technically, right? S minus K equals 6. Perfect. Who can give me an addition equation to compare S and K, or Susie's and Kim's? Gunnar?
What I would do is K plus 6 equals S.
Yes.
And also K multiplied by 4 would equal 8.
Yes. So we could take this problem one step further if we, Miles, were like the makers of this math book, and we could have asked our students to have compared these using multiplication also, couldn't we? Because if we did that, S would equal K times, remember I can do the little dot if I don't want to do the X, K times 4. Yeah. I'm glad you saw that. Khalid?
Is S subtract K equals 6?
Yes.
Yeah. You could just really add the 6 and the K and you'll get 8.
Yes, you can add 6 and K and you get 8. That's right. That's because addition and subtraction are inverse, remember? We can use one to undo the other. Yes, Nolan?
I just wanted to say that that the name Fred reminds me of Harry Potter.
Oh, yes. Oh, a good Harry Potter reference always makes me happy. Okay, number 7, write a multiplication equation and a division equation that compare the number of home runs Greta hit, we'll call her G, and Fred. Fred. Okay, who hit more, Fred or Greta?
Fred.
Okay, so we'll make his box bigger. I know G for George would be great. Okay, and Greta has a smaller box. Now we're thinking multiply and divide, which you smart mathematicians are already thinking. So what numbers can we put in here? Let's see, how many home runs did Greta hit? Chase, can you tell us how many home runs Greta hit? Yeah, I agree. And Lana, can you tell us how many home runs Fred hit? 18, I agree. Okay. Anyone want to give a multiplication equation a try? Cash?
6 times 2 equals 18.
6 times 2 equals 18 is correct. So let's replace those values with the variables.
6 times 2 equals 12. 6 times 2.
Oh, oopsies. My mistake. We'd made a double mistake. You made a mistake and I made a mistake. Everyone is helping us with our mistake and saying 6 times 2 is 12. So what do we have to do to get to 18?
6 times 2
6.
equals 2.
No.
6 times
6, 12, 18. So we need 6 times 3. Thank you for all of you who helped. So let's replace these values with variables. So instead of 6, let's write G. And we're going to multiply G times 3. And then we're going to we get 18, but we're going to write our variable of F. Thank you, Cash. Okay. Who can give us a division equation to relate these two? Amelia?
18 divided by 3 equals 6.
Yes. 18 divided by 3 equals 6. So let's replace the 18 and the 6 with variables. What would we get, Amelia?
Wait.
So, yes?
Divided by 6 equals. Wait.
Nope, nope.
Divided by 6.
We were trying to get to 6. So F divided by 3 equals, and instead of 6, we're going to write G. Great. How many more home runs did Vaughn hit than Greta? Vaughn and Greta. Okay, so I'm going to make my boxes because I like them. I'm going to do a Vaughn box and a Greta box. So I already know Greta has 6. Does Vaughn have more or less? More. So I'm going to make him a bigger box. And how many home runs did Vaughn hit? Abby, how many home runs did Vaughn hit? Can you look at the bar graph? He's the red bar. 12. Okay, so this question is asking how many more. So here I'm actually trying to solve to find the difference. Can anyone give me an equation that you would use to find the difference? An equation, Ella? I could do that. 6 times 2 equals 12, so we could say 2 times as many. Yeah. What if we wanted to know exactly how many more? Great. You could do 6 plus, let's call this like the difference. 6 plus the difference equals 12. Or 12 take away 6 equals the difference. And then everybody sees easily, because these numbers are so easy to work with, that the difference equals 6. Kate, what were you going to say about that? Oh, look at her getting tricky. She's saying V divided by G equals D. Yes, that is a valid equation for this comparison. If D is the difference. Yes, Ryan?
12 divided by 6 equals 2.
Yes, 12 divided by 6 equals 2. 12 divided by 6 equals D. Oh my gosh, your 8th grade math teachers would be so happy about this. This is all algebra. Did you know you're doing algebra? No. You're doing algebra. Okay, which player hit 10 fewer home runs than Vaughn? So we know that Vaughn hit 12. We just looked at that. And so what would 10 fewer be, Skylar? Right, 10 fewer is 2. And Skylar, who hit 2 home runs? Wah wah, poor Kim. Yeah, I mean home runs. Sometimes you hit none, right? Okay, moving on to number 10. This year, Fred hit 2 times as many home runs as he hit last year. Oh, he's having a good year. How many home runs did Fred hit last year? What are your thoughts on how we might solve that problem? Kaden, do you have any ideas? Oopsies, Annie. On how we might solve this problem? Fred hit 2 times as many home runs this year as last year. How many did he hit last year? Would you want to start with unit boxes? Okay, we could do like unit boxes for this year and last year. Right? And we know how many home runs he hit this year. Wait a minute. We know how many home runs he hit this year. We know he hit less last year, it said. Because this year we already put Fred hit 18, right? This year. Oh, so now this is saying if 18 is 2 times as many as last year, so we would take last year times 2, and we would get 18. How do you think we might be able to solve that problem? What do you think, Annie? Do you want time or help, Kaden? Help? Can you help him, Annie? If this year he hit 18, which is 2 times as many as last year, how many did he hit last year? You want time or help?
18 divided by 2.
Yes, Annie says 18 divided by 2 is going to tell us L, right? So last year he hit, shout out the answer, 9. Or we could have also put our equation right, L times 2 equals 18. Remember, that's the difference between a situation equation and a solution equation. Okay, because this one we can actually solve. All right, what do you think? Anybody scared of pictographs and bar graphs?
No.
Brilliant. Okay, let's do some practice since we did these two on our all together. And a best way to practice, I think I'm going to quickly assign some lessons in iReady. So number 8 and number 9, you guys might want to keep your activity books out just to have some notes. And number 8 and 9, will you issue the Chromebooks? And when you get into iReady Math, what will you do first? Teacher assigned lessons. What are you going to do first? All right, awesome. Listen for your number. Jackson and Zachary are going to call your number.